Alright, next up is our review on probability. First of all, we talked about factorial, and what factorial means is basically if we see, for example, 5 factorial, that means 5 times 4 times 3 times 2 times 1. It is basically the product of all of the numbers from 5 all the way down to 1. We also defined that 0 factorial is equal to 1. And we talked about how to rewrite a variable expression with factorials. So for example, if I were to give you n plus 2 factorial over n minus 1 factorial, what we would do to break this down is we would start with whichever one is bigger. And in this case, n plus 2 is bigger than n minus 1. So I would start rewriting the larger one in terms of the smaller one. I would say n plus 2, n plus 1, and I would just keep on decreasing by 1 until I get a match. Woohoo! Once we get a match, we put an exclamation point on the end. Oops, that should be a minus. And then both of these will cancel, and we are left with n plus 2, n plus 1 times n for our answer. Slot method is used when we are looking at a variety of choices in a specific order. So for example, if I want to know how many ways can I choose specific things out of a bag, and I'm going to be changing how many options are left depending upon what I picked out, then I would look at several slots and I would fill in the blanks. A combination, this is when order does not matter. And there are several notations that we saw for combinations. We saw the vertical column notation, we saw NCR, and we saw C, n comma r. And in all of these cases, the formula was n factorial divided by r factorial times n minus r factorial. Now permutations, these are used when order does matter. And we saw this abbreviated as NPR or P n comma r. And this formula is very similar, except it doesn't have the r factorial. That is the difference between the two. Now, I put a note down here that says the difference between probability of an event and the number of ways an event can occur. Basically, what I want you to think about here is that there can be a lot of ways that an event can occur, but the probability of an event occurring is always in between 0 and 1. 0 meaning it never happens, and 1 meaning that it's a sure thing. So we just want to read carefully as to whether or not we want to have a fraction where we look at all of the ways it can happen over all of the possible ways, or if we're just looking for the specific ways that that event can occur. Now we talked about the difference between multiplying and adding. So if multiple events are happening at the same time, then you are going to multiply their probabilities. So if I'm looking at how many ways can you select a jack and a 2 in a 5-card hand, that basically means I need 1 jack, I need 1 2, and then I need 3 other cards. So I have 1 jack, I have 1 2, and I have 3 other cards. Well, there are 4 jacks that I could pick, so I will have 4 choose 1. There are 4 2s that I could pick, so I'm going to multiply that by 4 choose 1. And then there are 44 other cards that are not jacks and are not 2s. So I'm going to have 44 choose 3. And then I would multiply all of those together. Now the next problem, I want to look at how many ways I can create the same outcome. So for example, I want to know how many ways can I select at least 2 jacks in a 5-card hand. When I see any words that imply an inequality, at least, at most, no more than, that's when I'm going to add all of the ways that that event can come true. In this problem here, I can have 2 jacks and 3 other, or 3 jacks and 2 other, or 4 jacks and 1 other. Since it is impossible to have 5 jacks, those are the only options that I have. And to finish those off, I would have 4 choose 2 times 48 choose 3, and that gives me one scenario that could make this outcome occur. Then I'm going to add it to my next scenario to make this outcome occur. So 4 choose 3 times 48 choose 2, and then plus 4, choose 4, times 48, choose 1. When we talk about permutations with repetition, basically what we want to do here is do n factorial divided by p factorial, q factorial, r factorial, etc., where p, q, and r are the number of repeats that we have, and n equals the total number of objects. If we look at the word Mississippi, we have 11 letters, so I would have 11 factorial divided by, and then there are 4 i's, there are 4 s's, and there are 2 p's, and I would go ahead and type this in. Now when we talk about circular permutations, there are a couple different rules that we need to remember. If it is a basic circular permutation, then we're going to do n minus 1 factorial. If there is a specific reference point, well, then that makes our circular permutation now appear linear. So in that case, we do n factorial. And then our reflection principle this says that if the object can easily be turned over in your hand, then you are going to divide the number of permutations by 2. When we take a look at these various notations, remember that our upside down U means and the regular U means union or, okay? And when events are independent, that means that the outcome of one does not affect the outcome of the other. So if we want to know the probability of them both occurring, then we multiply their individual probabilities. Now if the events happen to be independent, then we would do the probability of one times the probability of the other, given that the first occurred. So that vertical bar means given that the first one occurred. Now when I go to find my union of events, I need to subtract off any overlap. So what I do is I first find the probability of one occurring, then I find the probability of the other occurring. Now it's possible that the event occurred in both A and B, and so if that happened, then I counted it twice, which is why I need to subtract their intersection. Now if two events happen to be mutually exclusive, well, in that case, then that means then their intersection is equal to 0. Now my conditional probability is going to be found by the condition or the probability that both events occur divided by the probability of B occurring. And a phrase that I commonly said in class was the event that is after the bar goes under the bar. And we need to remember that whenever we are setting up these equations. With Venn diagrams, these are going to be useful when we have multiple events where we have overlap. These are not used with conditional probability. And that would be when we have those given that scenarios. Venn diagrams are really only helpful when you have people that fit in one category, that fit in another category, that fit in both. That's when a Venn diagram is very useful. Now, Bayes' theorem was where we took a look at conditional tree diagrams. And in these conditional tree diagrams, the second layer represented the probability that the first layer already occurred. If we wanted to find the and statement, remember that we multiplied. So the and was found by multiplying down the branches. And Bayes' theorem was on worksheet 11 in our probability unit. Our binomial theorem, this was used to expand something such as x plus y to the nth power, and we could also use it to find a specific term in our expansion. The formula that we learned, x plus y to the nth power, we were able to do the sum of all the terms, starting with r equals 0 to n of n choose r, and then we had our first term to the n minus r power, and our second term to the r power. Now, an alternate to using the NCR to get those coefficients was Pascal's triangle. And remember, Pascal's triangle started with a 1 and then a 1, 1, and then from there we were able to do 1, 2, 1, 1, 3, 3, 1, and just add those, add the two numbers diagonally above it to get the number below it. Some things that we talked about with our binomial probability was that if we are raising it to the nth power, there are going to be n plus 1 terms. If you want the sixth term, then remember that r would be 1 less than that, so r would be 5. And that's because my first term starts with r equal to 0. Then we took, and that was in worksheet 12. Then we took a look at binomial probability in worksheet 13. And what binomial probability says is that we're going to do, if we have n trials of an event, where the event can either be a pass or a fail, a success or a failure, we are going to say with n events, I want r successes, then I would do the probability of success raised to the r power times the probability of failure raised to the n minus r power. Now notice that these exponents are flipped of what we see above in binomial theorem. And an easy way to remember this is just we want r successes and the rest are failures, which is why it's n minus r. Now when we're doing expected value, and this was in worksheet 14, what we want to do is you want to sum up all of the outcomes that are possible times the probability of that outcome occurring. And we took a look at this when we were dealing with lotto tickets, the expected value of rolling a dice. We saw a problem with GPA, and basically this can only be used when the outcomes are numerical, and what this tells us is the value that we can expect to see if we repeated this event over and over for a very long period of time. And that's it.